In this lesson, we're going to be using scatter plots to describe patterns and relationships between quantities. The success criteria is, I can make a scatter plot, I can identify outliers, gaps, and clusters in a scatter plot, and I can use scatter plots to describe relationships, between data sets. A scatter plot is a graph that shows the relationship between two data sets. The two sets of data are graphed as ordered pairs in a coordinate plane. So for example 1, the table shows the ages of 10 adults and the number of gigabytes of cell phone data used by each adult in 1 month. Make a scatter plot of the data. Identify any outliers, gaps, or clusters. So notice in the data table, I have age in my first column, and then data used in gigabytes in my second column. And then in this graph here, I have my age on the x-axis, time is typically on the x-axis, and then the data is on the y-axis. So all I need to do is just plot these ordered pairs from the table. Now we're not going to get every single point plotted perfectly, but we're going to get as close as we can. So the first point is 37 years and 3.2 gigs of data. That's about right here. And I'm going to check off my little box after I'm done. And then the next one is 30 years and 3.3, a little higher right there. Then I have 32, 3.1, slightly above the 3 there. And then I have, let me check that off. And then I have 65, 0.9. So that's going to be over here. And then 0.9 is going to be right under the 1, something like that. And then I have 53, 1.8. So 53, 1.8 should be somewhere around here. Check that one off. Then I have 25, 3.5, right there. And then I have 59, 1.3, something like that. And then I have 30, 1.8. So 30 is right here. So go 30, 1.8 will give me something like this. And then I have 50, 1.9, just right around there. And last, I have 34, 3.3. Something like that. All right, so now I need to identify any outliers, gaps, or clusters. So an outlier is a data point that doesn't really look like it fits in with the rest of the data. So that's going to be this point right here. So we have an outlier, and that is going to be at 30, 1.8. And the interpretation of this is most people in this age range are using much more data, but this person is using much less data for their age range. We have a cluster of data in between the 25 to 37 range right here. So that's a cluster. It's when the data is really close together. So I'll say that's from ages 25 to 37. So that's my clusters right there. And then I have a gap, if we look at gaps. My gap is kind of in this range. I don't have any data right here. So that's from ages 37 to 50. So I've plotted my scatter plot, and then I identified the outlier, the gaps, and the cluster. And now we're done with this one. A scatter plot can show relationships between two data sets. So here we have positive linear relationship. So these points are kind of increasing at a constant rate. Obviously, they're not all on the same line, but they're close. As x increases, y increases. So when I increase my x value, my y value increases as well. A negative linear relationship is the same thing, but instead of as x increases, y increases, now as I increase x, as I go to the right, my y value goes down. But these are all pretty straight, and a linear relationship would be a good way to describe this. Next, we have a nonlinear relationship. So these points right here wouldn't really fit great on a line. They'd fit better in a curve here. So this would be nonlinear, but there is a relationship here. We can see the pattern. And then no relationship means that these are just kind of randomly scattered. We don't have any relationship that would be a good way to describe this data. So for example 2, I need to describe the relationship between the data in the scatter plot. Now, I know that as I'm increasing the television size right here in inches, the price seems to go up. Okay? Now, I want to see whether or not this is a linear relationship or a nonlinear relationship. So if I go back up here, a linear relationship means that a line would probably be a good way to describe this. Nonlinear means maybe a curve or some other sort of pattern would be better. And this does look like a line would be a good way to describe this. For instance, if I were to draw a little line, I could see that this line right here kind of is a good way to describe this data. Now, it's not perfect, but as I can kind of tell that this data trends on this line trajectory, I know that this is a good model for the data. So this scatter plot shows a positive linear relationship. It's positive because as I increase my x, my y also increases, aka if I were to draw a line through this like I did, the slope would be positive. It's linear because a line's a good way to describe it, and that's why it's a positive linear relationship. And now we're done with this one. For example 3, the table shows the amounts of fat and the number of calories in 12 restaurant sandwiches. How many grams of fat do you expect in a sandwich that contains 650 calories? So what we're going to do here is we're going to make a scatter plot of this data. So I'm going to plot these ordered pairs and then see the relationship so I can take a good guess on what the 650 calorie sandwich's fat content is going to be. So I'm going to plot my points. So I have 17, 400. And then I have 12, 470. Somewhere right there. Then I have 29, 540. Then I have 26, 512. And just as a reminder, these are not going to be super perfect, but they're going to be very close. Anyway, next I have 10, 420. And then I have 42, 740. And then I have 30, 600. And then 33, 640. And then I have 44, 790. And then 22, 510. And then I have 39, 610. And then I have 28, 510. So this scatter plot shows that my data is trending upwards. As my fat increases, my calories also increase. Okay? And if we look at what the question's asking, it's saying how many grams of fat do I expect for a sandwich that is 650 calories? Well, I can tell that my data is trending this way. So 650 calories is somewhere around here. So a good guess might be around 35. So if I had this point right here, so 650, and then like this, I could see that if I had a point right here, this would fit very well with my data. Now, this is not the only correct answer. You could pick any answer in this neighborhood around 35, but we could expect a 650 calorie sandwich to have 35 grams of fat. So we used a scatter plot to figure this out. We analyzed the data, figuring out what the trend was, and then we picked a good value that would match up well with a 650 calorie sandwich. And now we're done with this one.